Alright, so before I start this video, I do want to mention that this video is going to be pretty long. So feel free to skip by if you're just interested in the homework problems and how to work those out. But right now, I'm going to show you today's bell work. So today I will ask the kids, basically, what is the exponent for the 2 that gives us an 8? So what exponent gives the 2 an 8? So think about it. Well, we have learned that if we raise 2 to the third power, right? If we raise 2 to the third power, so basically, in this case, third power, we get 8. So if you don't trust me, you could just do 2 times 2 times 2. That gives you 8. So in this case, x had to have been 3. So the exponent here is 3. So in this lesson, what we're going to be learning is how do you find exponents. But right now, I just want you to try to guess. So this next one here, now this one was pretty easy because we've seen 2 to the third power being 8. But this one is a little tricky. Think about it. 3, what power for 3 gives you a 10? Well, we know 3 to the second power gives you 9. 3 to the third power gives you 27, but that's too big. So if I square 3, it's 9 and it's smaller than 10, so that's not good. 3 to the third power gives you 27, and that's too big compared to 10. So it must be an exponent between 2 and 3, so it must be a decimal number, right? So in your calculator, pause for a moment on this video and try to figure out what decimal number between 2 and 3 gives you a 10. See how close you can get before I give you the answer. All right, so I'm going to show you what is the answer here. The exponent, or the x here, is 2.0959, at least to the 4th decimal place, and then it goes on forever and ever. Did you guys guess that answer? No? Maybe not? No worries. I'm going to teach you how to get this number. So you're probably wondering, how do we get exponents if we already know the base and we know the value that we want? Well, here's how we do it. We use something called a log. Okay? So in your calculator, you're going to hit math. If you hit math, you know my favorite button is math. And you use the control pad, and you're going to scroll down, and you're going to find the button log base. And once you find that, you should get a log that pops up, and it's going to ask you to put a number in this box and a number in this box. And what you're going to do is you're going to plug in the base here. So the base in this case is the 3. So 3 here is your base. So the 3 will go in here. So it's kind of a tiny number. And then out here is going to be the number that you already have. So we want this 3 to be a 10. So the value, this is what we call the value, goes inside the log. And then it will give you the answer for the exponent. So it's going to give you the exponent. Okay, which is the 2.0959. And it goes on and on forever. Now, I'm going to show you how this is done in the calculator. So I'm going to show out this example using my calculator here. So when you're in class, please use my TI-84 calculators. It's the yellow ones. And that's going to really help you solve out these problems and find that exponents. So logs help you find exponents if you have the base and the value. So here we go. I'm going to grab my camera here, grab the video. Let's switch the camera. All right, so here you can see my calculator. Like I said, I'm going to hit the math button. And there we have all those cool features. But you want to use this arrow key and scroll on down to log base. And there it is. I'm going to hit enter on that, and it gives me this new function. And so, like I said, that's the little number that will go in, or the subscript is what we call it. And we're going to pop in our base. So let me scoot this over to the side. There we go. And so you can see my base here is 3, and my value that I want to stick inside the parentheses is a 10. So I'm going to put 3, and then inside the parentheses, I'm going to put in a 10. There we go. So that's what it looks like, and I'm just going to hit enter. and it gives me that number that we got here, right? So that's how I got the number. I was using logs. I also want to mention here, like, something easy to understand is, let's say I have a log, like I have 3, right? I have 3, and I want to know what exponent gives me 9. Now, most of us know that if you take 3 to the second power, you get 9. But if you didn't know that, you can do log base 3 and put 9 inside, and it should spit out the exponent that it's supposed to be. So let's try that, just to play with a little bit. So we have math. We're going to go down to log base and hit enter. And then I'm going to put a 3. And then I'm going to put a 9 inside. And so 3 to the what power gives me 9? Well, it's 2. And then I kind of already knew that, 3 to the second power gives me 9. So logs help you find the exponent that you desire. All right, so I hope that video helps you there. Let's get into some homework problems. So let's try out packet 12, page 3. I'm going to turn to page 3. And I'm going to, let me see if I can pause this video, I guess. There we go. So I'm going to go to page 3 of the packet and start with the first 3 problems because they're just using the calculator. So we can get some more practice on that. All right, so we're going to evaluate the following logarithm. So logarithm is basically log. So log is like the nickname we use for logarithm. It's just a word or something we use to help us find the exponent. So this one here, I'm just going to use the calculator. But what it's going to be asking for is like take the log base 5, 25. So if I were to put this in my calculator, let me grab my calculator so that way you guys can kind of see this as I'm doing it. Let's put this to the side here. All right, so in my calculator, I'm going to do math again and scroll down to log base and hit enter. And then I'm going to plug in 5. So if I plug in 5 and then plug in 25 gives me this, and I'm gonna hit enter and I get a 2. And let's see if that makes sense. So this is a 2, and I think that makes sense because in this case the base here is 5, right? So 5 to the what power gives you 25? Well, 5 squared would give you 25. So I think this is very reasonable. This one here, it says log base 10 to 1,000. So if I were to put that in my calculator, I just get a 3. Because 10 to the third power, if you multiply 10 3 times, you get 1,000. Then this one here is 4 to the 1 over 64. So if you were to do that one there, let's try to do that one together in the calculator. Is there a way I could do that without making another? Oh, well, it's fine. So if you were to do this one in the calculator, you would do like log. Shrink this a little bit. There we go. Log. And to do a fraction, you want to do division, 1 divided by 64 in the calculator. And then once you press that in, you get -3. So if you want 4 to become 1 over 64, you have to raise it to the -3 power. And then that's it. So hopefully this helps you a little bit out on the packet. The first 3 problems are already done for you. Let's go into what are logarithms and how do you reverse from a logarithm to an exponent. So logarithms or logs are the inverses of exponentials or exponents. So in this case, you want to ask yourself when you're switching from a log to an exponent, you want to ask yourself, what is the base for the log? The base is always the tiny number in the middle, and in this case, it's the b. So you have the base in the middle, and then you always have the exponent on the other side of the equal sign. So the exponent is the x in this case, because logs give you exponents, so that's what it equals. So we always put the base and exponents together to get the value. So inside of a log, the a here represents the value of what you're supposed to get after you take the log. Okay? And so this helps us switch back and forth from a log to an exponential. We can switch back and forth. We just have to ask ourselves, what is the base, what is the exponent, and what is the value that you get after you take the exponent? So let's try to rewrite the logarithm to an exponential form. So you can see all of these problems are a log. So this first one here, ask yourself, what is the base? Well, the base is always a number that's the middle number, and it's kind of written really smallly, or like the subscript. So in this case, the base is 2. So I'm going to write down 2 as my base. And then this 2 needs an exponent, and well, the exponent is what the log equals, so the 5. So this is going to be 5. And then this equals 2 to the 5th power equals whatever's inside the log, and inside the log is the 32. So that's your value. Or in this case, 2 to the 5th power gives you 32. And then that's it. That's your final answer. So I've just written this log into a exponential form. All right, this next one here also has a base of 2, so I'm going to grab that base there, the 2, and you would have 2 to the negative 1 power, because the exponential, or the exponent here, is the negative 1. It's what the log equals. And then this 2 to the negative 1 power equals whatever's inside the log, so the 1/2. And that makes sense because we said last time 2 to a negative, like when you have a negative exponent, you always put the number in the denominator to make it back into a positive number. So that's what happened here. All right, and then the next one here, this is log base 10, 1 equals 0. So this base here is a 10. And it looks like my exponent here is a 0. So 10 to the 0 power gives me 1, right? Anything to the 0 power gives me 1. But when I see that the inside of the log is also 1, it kind of confirms, yeah, 10 to the 0 power gives me 1. Oops, I meant to do that with a pen. So that's it. I've just transformed them to exponentials. Now let's try to do reverse. If I gave you an exponent, can you reverse it to a log? All right, so to rewrite these exponentials to log, you want to start by writing a log, probably. That's the first thing you want to start with. So we're going to write a log, and then we have to ask ourselves, well, the small number that goes here is the base. The base here is 15, so I'm going to grab that 15 because it's my base. And then I'm going to grab my value because this 15, when I raise it to the 3rd power, I get 3375. So that's going to be what my log has inside. And then the exponent that this number produces is 3. And then that's it. That's my log. So notice how I put the exponent after I got done with the log. So the exponent is what the log will equal, whereas the value here is what you put inside the log. And then here, oops, sorry, I didn't mean to do that. Here we have a base of 6, so this is going to be log base 6. So that's my base. And inside the log, I'm going to have a 1 over 6, 36. And it equals the exponent negative 2 because that's my exponent. And then that's it. That is my equation. All right, so let's try out a couple of homework problems here from each of these categories, and then let's get into graphing next. So in the homework here, this is packet 12 again on that 3rd page. Oh, sorry, packet 12, page 3. So we're changing the number 4 and 5. We're changing these logs to an exponential form. So to start with, ask yourself, what is the base, right? Because you need an exponential form, you need a base. So it's 3. Let's So we're going to have 3, and the exponent here is 5, because it's what the log equals. So this is 3 to the 5th power equals whatever's inside the log. So in this case, 243. So 3 to the 5th power equals 243. And then that's it. This one here has a base of 4 for this log. So base is 4. Exponent here is 3. So this is going to be 4 to the 3rd power. And 4 to the 3rd power gives me 64. So this answer here will be 64. All right, and then this one here is an exponential to a logarithm. So this one has the exponent already. So to write at logarithm form or log form, you just start out with a log. I'm going to write log, base, and this base here is a 2. So I'm going to write a 2 here. And then I need to write the value that this log will be after you take the exponent, which is 8. So in this case, 8 equals the exponent, which is 3. So this was the value, and it goes there on the inside. And then your exponent was 3, and so that goes on the outside. So there we have our log. The next one here, we have a base of 8. So we have log 8, 1 over 64 equals the exponent, which is negative 2. All right, and then that is our final answer. Okay, so I think we're getting pretty good with exponential and logarithm and how to switch them around. I think we're ready for graphing here. So we're going to do 2 journal problems, and then we'll do all of the graphing problems together at the very end of the slide. All right. So let's just start off with a really simple basic log. And this log, I made the base of 2 and then just put an x. Nothing fancy here. So the first thing I want you guys to realize is in your calculator, logs are really weird, okay? So I want you to first try in your calculator, log 2, plug in a 0. And then try plugging in negative, like a negative 1. And maybe I'll just plug in a positive just to see if it takes a positive. So when I plug in 0 into a log, turns out it won't like it. And it actually has no solution, so it's undefined. Okay? A log does not like zeros. Logs also don't like negative numbers, so if you stick in this negative 1, it's also undefined. Now, if you stick in log 2 to the 1st power, you get 0, and that's actually a number that we can work with. And that makes sense because 2 to the 0 power gives you 1. Anything to the 0 power is 1, right? So, like positive numbers, logs will be okay with. If you plug in a positive number, it likes it. But if you put in a 0 or a negative number, it's going to reject it. Which tells me that we have a vertical asymptote. A vertical asymptote is going to be on this grid at x equals 0. Because when x equals 0, or when I plug in 0 in for this x, right, it rejects it. So that means it cannot be at x equals 0. So one way we can figure out the vertical asymptote without, always investigating like this, is you can take the inside of the log. So you take the inside of the log, and you always set it equal to 0. So if I just set x equal to 0, because that's the only thing inside my log, well, that means that the asymptote has to be at x equals 0, and so this is at x equals 0, and I've already drawn a vertical dash line on the at x equals 0. So vertical lines or vertical asymptotes are up and down, and they are represented with x's instead of y's. And so because it hits it at x equals 0, then that's why this is x equals 0. All right, now let's get into how do we actually make the curve. So I already know that the curve won't show up on this side because I tried plugging in a negative number and I got it to be undefined. So there is no picture that's going to be on this side. It's probably going to be on this side. So to do that, it's really hard to graph a log problem. So what we do is we reverse it to a exponential. So we're going to change this guy to an exponential, and to do that, we have to ask ourselves, what is the base here? Well, the base here is 2. So we're going to use a 2. And then here's the part where people get off guard. Which one of these is the exponent? So take a look. This is the log, and we said logs produces or equals the exponent. So in this case, the y here is the exponent. So this is 2 to the y equals whatever's inside the log. So inside the log is x. So I've just switched this log into an exponential, and the reason why is because it's easier to graph an exponential. In fact, we learned how to graph an exponential a couple of days ago. So let's use that skill. Now this time it's going to be a little bit different because you might notice that the x here is not the exponent, it's the y that's the exponent. And that's just a little bit reversed than what we are used to thinking. But we can still make a table. So we're going to use x and y, but this time around I'm going to be a little bit more strategic. Because I notice y is the exponent, it might be easier for me to choose the y, and then when I plug it in, automatically have the x value, right? Because x equals 2y, if I just plug in my y that I know, I can get x easily. So this time I'm going to actually choose the y values, and I'll just choose the same old y values, choose them to be easy. So we're going to choose the y values because they're easier. So we're going to say 0, plug in for y, so this is 2 to the 0 power, so 2 to the 0 power, which is 1, anything to the 0 power is 1. If I plug in 1 in for this y, this is 2 to the first power, which is 2. And if I do the next one, 2 to the second power is 4. So here I have my x values now. So if these are my x values, I can just, graph them with my y values. So this is at 1, 0. So 1, 0 is right here on the x-axis. Oh, and it hits it on the x-axis. So if this point is on the x-axis, that means it had to have been my x-intercept. So 0, 1 is my, 1, 0 is my x-intercept, which is also why I recommend that you plug in 0 when you're graphing so you can figure out what the x-intercept is. All right, and then the next thing here, we're going to figure out what is the, I was trying to think of something and then I lost my train of thought. What is it? Oh, I was going to plot these points. So I already plotted 1, 0, which is right here. And now I'm going to plot 2, 1, which would be right here. And then 4, 2 would be a little bit forward. And so then here is my curve. And then this side, because there's an asymptote, I have to go to the left, but I'm going to glide downwards. Because I still have to connect this to the left side, I will have to just naturally curve it down so that way I don't hit the asymptote, because I don't want to touch the asymptote. So looking at this, it's going from, well, the furthest x that it can go on the left side is basically 0, right? It can't pass 0 because of the asymptote. So it goes from 0 to positive infinity because it points to the right. And so we're going to use parentheses because we can't touch 0 because it's an asymptote. And we can't touch infinity either, so it's it's a parentheses. The range, on the other hand, this is pointing down, right? And whereas this one's pointing upwards, so the range here is all real numbers because it points down with an arrow and up with an arrow. So that means it's always going towards the negative infinity or positive infinity. All right, so let's do one more of these before we get into the homework here. So this one here, we have a log, and this log has an x plus 2. Now, you might remember me saying this in the last slide, that you always, if you want to find the vertical asymptote, you just take the inside, and you set it equal to 0. So if you set this equal to 0, you'll have to subtract the 2, and then that cancels, so x equals negative 2. So that means that the vertical asymptote is at x equals negative 2, which is right here. So I'll draw my vertical asymptote using my dashed line at x equals negative 2. So looking at this, I'm about to draw the curve here for my graph. And I also want to mention, a lot of people, when they see this problem, they also remember like, hey, that's a parentheses and it says plus 2. So they might remember this as being left 2, shift left 2, and that actually also works here. If you shift left 2 from the origin, you also hit it at x equals 2. So that's also one way you can solve out the problem. Thought I'd let you guys know. Okay, let's get back into the problem. So f of x is on this side, but remember f of x is just y. And then we're going to switch this to a exponential graph. So here we go. The base here is a 4, so I'm going to grab the 4 and raise it to the y power, because that's the exponent on the other side. And this will equal x plus 2. Here's the thing. When you're solving it out, it's really important that you try to get the x by itself, because we typically want to plug in y. So if you don't solve for x, you're going to have to solve it later to figure out what x is. So I recommend you solve it now. So I'm going to subtract 2 on both sides, and then this x comes down. Now do not subtract this 2 from the base, because that base is holding a y, so you can't combine like terms like that. So you're just going to have to drop it down. So this is 4y minus 2, and now the x is by itself, so I'm going to use this as my equation. So making my table here. Oops. Should be a black line. There we go. So this be x, y, and again, we're going to choose our y values because they're a little bit easier to handle here. So if I do 4, plug in 0 minus 2, because I'm plugging this 0 into this equation. If I work this out, this will give me, well, 4 to the 0 power is 1, minus 2 is negative 1. So I have a negative 1 first. If I plug in the next number, 4 to the first power, is just 4. 4 minus 2 is 2. And last but not least, 4 to the second power is 16, minus 2 is 14. So if I graph these, this is at negative 1, 0, which is right here. And then I have it at 2, 1, which is right here. And then I have it at 14. So I'm going to mark this at 14 and go up 2. But this is going to extend upwards, and this one's going to extend downwards, like that. And then that's pretty much it. We have our picture here. Our x-intercept, as you can see, is right here, which was at negative 1, 0, so I might as well write that in. And then our domain is going to be restricted at the asymptote, so it's restricted at negative 2 to positive infinity. And then range is all real numbers, because this curve points down with an arrow and up with an arrow, so it's going to positive and negative infinity when it's going up or down. All right, so I think we're ready for some homework problems. So in the next slide, I'm just going to be working those 3 graphs here. So just follow along if you're having trouble with the homework. Okay, so the first one here is a log base 6x. So first off, like I said, this is an f of x. So remember, that's just a y here. So I'm going to replace that with a y. And before I switch this out, let's also just check what is our asymptote, our vertical asymptote. So this vertical asymptote, or the inside the log here, is just an x. So we can just say that this is set the inside equal to 0. Well, x equal to 0 is x equal to 0, right? So our asymptote is at x equals 0. Let me write that bolder. And so that means I have a vertical asymptote going down x equals 0. And now I'm going to try to graph my my log. But here's the thing. I need to switch it to a exponential. So my base here is a 6, right? My exponent here is a y. And then this will give me x. So my base here was a 6. My exponent here was a y. And this is going to give me x. And so when I look at this, like, okay, now I can make a table, and we like to choose the y values because it's easier. So we're going to pick 0, 1, 2, because it's probably easier to plug in. If I raise this to the 0 power, this is like 6 to the 0 power, which is 1. 6 to the first power is 6. 6 to the second power is 36. So when I'm graphing this, the first point here is going to be at like, 0, 1, 0. Which is going to be right here. And the next one here is 6, 1. So over 6, up 1. And then the next one here, I'm not going to really graph it, but it's at 236. So you can imagine you would have to extend this really far, like 36, and then go up 1. So you can see this is really growing on this side. And then this side, you're just going to glide next to the vertical asymptote, so you can just slide down. So the other side, one side should be going up and the other one should be going down. They're opposites of each other, okay? So I don't want to see both sides going up. Now the x-intercept here looks like it's at 1, 0. I can see that on the graph, so that's the coordinate for the x-intercept. And the domain here is being restricted from 0, but it does go on to infinity because it's going from 0 to infinity. You can see it's stopping at 0 and going off to infinity. Range here is pointing down and up, so all real numbers. All right, so let's get into the next one here. The next one's a little bit tricky. As you can see, the vertical asymptote here is going to be shifted, right? And this is x equals 1. So if you set that equal to 0, that means you would have to add 1 to both sides. So our asymptote here is at x equals 1. Or just remember, if you have a negative sign, you shift to the right. So x equals 1. So this is going to be a vertical line right here. Okay, so here's my vertical asymptote, and the next thing I need to do is probably figure out what my function looks like as an exponential. So I'm going to change this f of x to a y. So this would be y equals log base 2x minus 1. So first ask yourself, what is the base? So the base here is a 2. And then the exponent here is a y, right? Because that's on the other side. And then it's going to equal everything that's inside the log. So that's going to be x minus 1. Now, hold up, I noticed that the x is not by itself. So if you remember in the previous slide, we said that in order to graph it, it might be easier to get x by itself first. So I'm going to add 1 over. Cancel. X drops down. Now x is by itself. And then this side I have 2y plus 1. And then this is the equation I want to work with. Whereas like this one was the equation that I wanted to work with. Now I can make my table and choose my y value and find my x. So this is going to be, I'll just choose the same numbers, 0, 1, 2. Then I'm going to plug in 0 plus 1. Okay, 2 to the 0 power is 1 plus 1 is 2. 2 to the first power is 2. Add that with 1, that's going to be 3. 2 to the second power is 4 plus 1 is 5. So our first point here is 2, 0. So 2, 0 is right there. And then our next point here is 3, 1. So 3 up 1. And then our next point is 5, 2, which would be right here. If I graph it, this starts to curve out, but this one will just extend down as it glides next to the vertical asymptote. And my x-intercept here is at 0, 2, 0. Yeah, because that's my x-intercept, so that's at 2, 0. Domain here, it's being restricted from 1, and then it can go onwards to infinity, so 1 to infinity. And then the range here is always all real numbers. All the ranges are going to be all real numbers. I might as well just do that one. It's all real numbers. Because I know it's a logarithmic function, so it's going to be all real numbers. All right, now we're to the last one here. Let's squeeze that. There we go. Okay, so again, this is your y here. Now, before we start switching them to exponential, let's just remember how to find the vertical asymptote. So the vertical asymptote here, here's the log, and inside the log is just an x. So if I set this equal to 0, it's just going to be x equals 0 for the asymptote. So again, we have another asymptote at x equals 0. Popular one today. All right, and then the next thing is we need to find the equation. So our equation here is y equals log. Let me write it bigger so that way you guys can see the screen. So here's the equation. The first thing I notice, looking at this log versus the other logs, this log has something outside of it, right? The 2 is part of the log, the x is part of the log because it's inside the log, but the 5 isn't. 5 is not part of the log. So the first thing you'll have to need to do is get the log by itself. So we're going to scoot this 5 over by adding it over. This will become an important skill to have later when we're solving. So let's practice that now. So you're going to add the 5 over and now have this log by itself, like that. Then the log is by itself, so now you could do your switching where you switch it to a exponential. So if we switch it to an exponential, our base here is a 2, right? So we're going to make this a 2. And then our exponent is what the log equals. So it's all of this. This is all the exponent. So it's y plus 5 equals whatever the log equals inside, which is x. And now we have our exponential form. So here's our new equation we get to work with. Let me shrink this down just a little bit. There we go. And let's make our table here. So you can pick whatever y values that you want. Now I'm going to pick 0 because, well, I have to pick 0 to figure out the x-intercept. But I also noticed that the exponent here is has a 5. And you can be more choosy on what you want to plug in, because if I plug in 1, I have to add 1 to 5, and then the exponent becomes 6. So maybe I want to choose a negative number to make this exponent smaller. Let's just be more playful, because I've done a lot of these problems where I chose, 0, 1, and 2. Let's be a little different here. I'm going to make this more convenient on myself by trying to making this exponent smaller. So how about I throw in negative 5? Yeah. If I throw in a negative 5, I know that that's going to make that probably decrease a little bit more. Let me choose negative 4 too. Negative 4. I'm just going to be a little bit more choosy. So if I plug in 0, I'm just going to end up having, let me erase this and make some more room here. So this is going to be 2, 0 plus 5, which is 2 to the 5th power. 2 to the 5th power is 32. So 32. So on this graph here, when I plot the, I guess in this case the y-intercept, because I plugged in 0. So the x-intercept, the x-intercept is 32, 0. And so I would have to extend my graph all the way until it gets to 32, and then finally plot my point right there. That's a really, far out extension, right? Because the number here, the exponent, are so big. And then this next one here, I have a negative 5, and I chose that number so I can decrease the power a little bit. So if I chose negative 5, add that with 5, this is 2 to the 0 power, so that's a 1. And so this would end up being at 1, when x is equal to 1, it's negative 5. So 1 is right here. I would go down to negative 5. So it's like right here. And then if I do the next one, this is 2, negative 4 plus 5, which is going to give me 2 to the 1st power, which is 2. Yes. So in this case, at 2, it's going to be negative 4. So I'm going to graph that point, which would be right here. And so if I were to try to connect the dots here, this is going to curve outwards later, but this part's going to scoot down. Okay, so the domain here, we can definitely see it's being restricted from 0, and then it keeps going on forever to a positive infinity. And then that's it. All right, so quite a bit of variety here. Key points here is that if you want to find the vertical asymptote, just take the inside of the log, set it equal to 0. Next thing is, to make a chart, you have to change your log to an exponential. So make sure you know which one is your base, your exponent, which is usually the y, and then the value that it equals is usually whatever's inside the log. Another tip is that basically make sure the log is by itself before you decide to rearrange the equation, okay? So, like this one here had a -5 on the outside. I had to push it over first. And also, like, I choose 0, 1, and 2 all the time because they're convenient, but you don't have to. There are certain situations that other numbers might be better. Like in this case, the exponent was so high, so maybe I wanted to decrease it by choosing, like, negative values to kind of cut it off. All right, hopefully this helps you guys out. Sorry if this video was so long, but until next time, guys. See ya.